Ever thought about how light from distant stars, millions of light years away, reaches your eyes? A simple question, yet it opens the door to an incredible journey into the depths of our universe, guided by the principles of space-time and the speed of light. Just imagine, the glimmering specks of light we see in the night sky have journeyed vast cosmic distances, uninterrupted, until they meet your gaze. It's a journey that unfolds over millions, even billions of years. How is it possible? Well, it's all about the intriguing nature of space-time, a four-dimensional fabric woven together by the universe itself. And the speed of light? It's the cosmic speed limit, the ultimate velocity at which information, or in this case starlight, can travel. In this vast cosmic theater, space-time and light speed are the lead actors, playing their parts in a grand performance that unfolds across the universe. The secret lies in the fascinating world of space-time and the speed of light. Ready to explore? Scene script. Imagine a fish in a pond. It can move forward, backward, and even up or down. But can it step out of the water? No, that's space-time for you. Let's simplify this further. We live in a three-dimensional world with the ability to move in three directions: left or right, forward or backward, up or down. But like the fish in the pond, we can't step out of this three-dimensional world. We're confined within the boundaries of space-time, much like the fish is confined to its pond. Space-time, as the name suggests, is a four-dimensional structure, combining the three dimensions of space with the single dimension of time. The concept is pretty straightforward. It's the fabric of the universe, the stage on which all events play out. But here's the catch. It's not flat or static. It's dynamic. It curves and bends, influenced by the presence of mass and energy. Imagine a large rubber sheet stretched taut. If we place a heavy ball on the sheet, it will sag, creating a curve. This is similar to how mass and energy warp the fabric of space-time, creating what we perceive as gravity. The heavier the object, the greater the curve, the stronger the gravity. But what about time? How does it fit into this picture? Well, time is the fourth dimension in our space-time fabric. And it's not separate from the three dimensions of space. They're intertwined, inseparable. This is why we often hear physicists talk about events rather than places. An event is a specific location in space at a specific point in time. So, in our universe, we're all like fish in a pond, moving in our three dimensions, while also moving forward in time, carried along by the current of space-time. We're all passengers on this space-time journey, unable to jump off, just like the fish can't leap out of its pond. Now what if we introduce light into this equation? Scene script. Light, the fastest thing we know, travels at a mind-boggling speed of 299,792 kilometers per second. Imagine a beam of light starting its journey from our sun. In just over 8 minutes, it would reach us here on Earth. If it kept going, it would fly past Mars in another 4 minutes, and past Pluto in about 5.5 hours. In just over 4 years, it would reach the nearest star to us, Proxima Centauri. That's light speed for you, and it's not just fast, it's the universal speed limit. But what does this have to do with space and time? Well, according to Einstein's theory of special relativity, light doesn't just travel in space, it travels in something called space-time, and here's where it gets interesting. As something moves faster through space, it actually moves slower through time. This is known as time dilation. Now, if you're thinking this sounds like science fiction, you're not alone. But it's been tested and confirmed time and again. GPS satellites, for instance, have to account for time dilation because they're moving so fast. If they didn't, your GPS would be off by about 7 kilometers a day. So, light, zipping around at its incredible speed, is actually experiencing time at a slower pace. If you could ride a beam of light, which sadly you can't, you wouldn't age, you wouldn't get hungry, you wouldn't even notice time passing, because for you, time would stand still. But remember, light isn't just a speed demon, it also gives us a way to look back in time. When we gaze at stars, we're seeing light that has traveled for years, even millennia, to reach us. We're seeing those stars not as they are now, but as they were when that light began its journey. But how does this all relate back to Einstein and his theory of relativity? Einstein, a name synonymous with genius, gave us the theory of relativity, forever changing how we perceive space and time. Let's dive into the genius of Einstein's mind and unravel the theory of relativity. This theory comes in two parts: special relativity and general relativity. Special relativity, proposed in 1905, introduced us to the fascinating concept that the laws of physics are the same for all non-accelerating observers. It also proposed the speed of light within a vacuum is the same no matter the speed at which an observer travels. Einstein's special relativity tells us that space and time are intertwined into a four-dimensional fabric called space-time. But what's even more mind-bending is that this fabric isn't flat. It curves in the presence of mass and energy. This is where general relativity, proposed in 1915, comes into play. General relativity extends the special theory to include gravity, describing it as the curvature of spacetime caused by mass and energy. Picture spacetime as a rubber sheet. When a heavy object, say a bowling ball, is placed on it, the sheet curves around the object. This is what happens in our universe. Planets and stars cause spacetime to curve around them, creating the force we know as gravity. Now, where does the speed of light come into the picture? Well, according to Einstein, the speed of light is the only thing that's constant for all observers, regardless of their motion or that of the source of light. This speed limit of the universe is woven into the very fabric of space and time. The theory of relativity also introduced the concept of time dilation. It states that time slows down or speeds up depending on how fast you move relative to something else. This means that if you were to travel near the speed of light, time would slow down for you relative to someone stationary. This is not just theoretical but has been observed and measured with precise experiments. The implications of Einstein's theory are vast and profound. It has revolutionized our understanding of the universe, leading to the prediction of black holes and the Big Bang. It has also made possible the GPS technology we use today. Without accounting for the effects of relativity, GPS coordinates would be off by several kilometers. Einstein's theory of relativity gave us a new lens to view the universe where space-time and the speed of light play critical roles. It taught us that the universe is a woven tapestry of space and time, bending and curving under the weight of mass and energy. It's a universe where time and space are fluid, not fixed, and where the ultimate speed limit is the speed of light. This is the universe as Einstein saw it, a place of mystery and beauty, waiting to be explored. In this journey through space-time, we've uncovered some fascinating aspects of our universe. We've delved deep into the mysteries of the cosmos, and brushed up against the very fabric of reality. Let's take a moment to revisit our discoveries. First, we unraveled the enigma of space-time. It's not just a stage where the cosmic drama unfolds, but an active participant in the narrative. Space-time is a four-dimensional fabric, woven from the threads of three dimensions of space and one of time. Its curvatures and distortions caused by massive objects create the phenomenon we perceive as gravity. Next, we shone a light on the speed of light. Not just fast, but the ultimate speed limit of the universe, clocking in at roughly 186,000 miles per second. Nothing can outrun it, not even time itself. This cosmic speed limit sets the pace for all that happens in the universe and is a fundamental part of our understanding of space-time. Then we ventured into the realm of Einstein's theory of relativity. We learned that space and time are not separate entities, but interconnected parts of the same continuum. We realized that the speed of light is not just a number, but a key that unlocks the relationship between space and time. Einstein's theory showed us that time can slow down or speed up, depending on how fast you're moving, or how close you are to a massive object. In essence, we've learned that space, time, and light are intricately linked. They weave together to form the tapestry of our universe, each impacting the other in profound ways. The understanding of these concepts doesn't just satiate our curiosity, but also paves the way for scientific advancements and technological breakthroughs. Space-time and the speed of light, two fundamental aspects of our universe, forever intertwined thanks to the genius of Einstein.